Hello, I'm Max Regenfelder from the University of Stuttgart, and I will present you the case study 9 of the Fibre project. It's about the mechanical recycling of glass fiber reinforced plastics, and it addressed the automotive sector. In this case study, a plastics component of the braking system with a high security relevance was chosen as a flagship example for the incorporation of recycled materials into it. It's about the mechanical recycling of short glass fiber reinforced PET plastics. That means production residues, so-called sprues, as you see in the photograph down there, are regranulated in a mill and reincorporated into a new component. What was a special feature of this case study is that there are many changes in the material properties from this recycling process. That means if glass fiber reinforced plastics are recycled, the fibers get shortened and other materials properties change as well. This case study is highly innovative because for the first time in an automotive security relevant use case, it is shown that the technical requirement of the component can be met with mechanically recycled plastics. And normally, or the current treatment practice for glass fiber reinforced plastics is downcycling. That means they are incinerated or incorporated in concrete. So it's some kind of downcycling for every option of these two. This is also interesting for the automotive sector because the use of recycled materials has become a strategic matter in automotive. Some of the big automotive OEMs already state that it is a mean to offset the rising prices of raw materials. What is interesting in this case is that there is, on the level of the single engineer, somehow a reluctance to use recycled materials because there are prejudices regarding the durability or the properties of it. So Continental has started this case study also as for unlocking future applications beyond the low functional and low material requirement applications in automotive, where recycled plastics is used in today's industry. For transferring this serene approach to the automotive sector, 4 case-specific goals were established. The first was the development of the component itself. The second, the elaboration of the material testing processes and the specifications, and the identification of the critical process parameters for the recyclant. And this recyclant has to be incorporated into the production process. That means there were also changes and adaptation in the production process and establishment and design of the recycling process. The last goal, the design and establishment of an industrial network, the manufacturing of prototypes and starting mass production of the component. These are the practical results of this case study. That means that the results are transferred to the automotive practice. All of these 4 goals were successful and have led to the pilot industry network for the first start of serial production. It consists of the material supplier, the tier 2 supplier, that means the plastic component manufacturer, Continental as the producer of the braking system, and 1 pilot OEM customer. For the further results, the successful transfer to mass production was quite a big success. That means annually there are 600,000 pieces of this component for a pilot customer OEM with a recyclate share of 1/3. And so there is really a practical output. And this case study also proves that the recyclate share in this component could be also be up to 100%. And economic benefits were seen in the material cost savings, which outweigh the infrastructure costs. That means for the milling process, for the recycling mill, in the midterm. Social benefits were also assessed and are seen in job security from being on the competitive edge of technology and the public education. That means overcoming the prejudices regarding recycled materials. The main driver for the greenhouse gas emission savings was the primary material substitution. And that means the greenhouse gas goal was mainly accomplished by the use of recycled materials. For the main goals of Serene, we can state that 2 out of the 3 main goals were fulfilled by serial production and the practical demonstrator. The waste reduction goal is fulfilled because all of this form of production waste, the sprues, are collected and regrind it in the recycling mill, and only about 5% is dustless when milling it. The greenhouse gas goal was also achieved by 34% of reduction. It's also more than the one third because there are shorter transportation distances. Only the water consumption goal was not fulfilled, and it only decreased slightly by about 15% because of the additional electricity consumption when milling the spruce. What are the lessons learned from the view of the company? Recycling material doesn't mean that only a change of input material. There are interdependencies between the changed material properties, the production process, the component design, and the specification. That means all of these four fields are interdependent, and you have to manage them each. Including recycled materials, therefore, adds complexity for manufacturers. And what in the case of this fiber-reinforced material was also important is to control the sources where it comes from, because those properties change with every recycling loop the material has passed. That means traceability is mandatory for a security relevant use case. So only recycled material is used which is only recycled once. And this is also assured by a close cooperation with the plastic component manufacturer. And as a big success, Continental is confident having unlocked further applications for recycled materials in automotive. If you want further information, please see the article in the journal Waste and Resource Management, which is to be published soon, or contact Dr. Stefan Dulli from Continental. Thank you for your attention.